Hi, everybody. How are you doing? Ready to do some assembly? The moment has arrived. I hope you're doing good. Okay, check out Lab 2. Hi, download it and we'll talk assembly. Okay, so we're waiting for a few more to join us. We have a few minutes. Check out Lab 2. If you have Windows PC, download the LC-3 simulator. I'll walk you through the installation once again, and then we'll talk about the program. Are you using Windows PC? You have Windows 10? Okay. Did you unzip it? I'll walk you through it. If you didn't unzip it and you try to launch it, it's not gonna work.
Hey, Professor.
Hi, how are you doing?
Good, and yourself?
I'm hanging in there. I've been in meetings since 8 a.m. this morning. We're trying to launch the Clean Water Project, teaming up with the school in Iraq. And so I've been in conference call all morning and then trying to work through some materials. But yeah, I meant to get some grading done, and sure enough, but tomorrow while I'm in the meeting, I'm gonna try to like pause and do some grading. Hopefully I can knock it out by Saturday at the latest. But yes, thank you for asking.
No problem. Quick question. About the LC3 thing.
Uh-huh.
Do you mind going over on installing it and stuff, or like?
Yes, we'll do that. I also wrote that in the lab, but the lab was written for the students that were using the school computer. So I'll walk you through that. Okay, no problem.
All right, thank you.
Yep. All right, it's 6 o'clock. Welcome back. Let's get started. Hi, everyone. Are you excited to do LC3?
Hello.
Hi. So I'm excited to do some assembly. All the binary and hexadecimal is behind us. We will use our knowledge and move forward with programming. Just a quick announcement. I had posted an extra credit module for Clean Water Project. So if you like to attend, we close registration on the 28th. I know it's really close, but we are teaming up with the school, with the university in Iraq, and some of the students will be joining our students in designing a water filter, and then I conduct these seminars, so we will do some design with the I team, and then we will do some C programming with Arduino to make sensors. So if you have some free time, you like to join, check out the module, and you can earn some extra credit with it. And I will have other opportunity for extra credit. So, all right, let's get started. I'm gonna go into screen share. Let me get to our class. Sorry, I was in CIS7 because my Zoom video was delayed. They just released it right now. So in this week, we are going to work on lab 2. And I will post the video as soon as I can get the Zoom download. It's been pretty slow of late because everybody's on it for all the school. So please check out lab 2, and then we will go through the instructions. So here's your lab 2. So before we start, let's talk LC3 a little bit so you can have a better understanding, and then I'll walk you through the installation and the programming. So as I emphasized last time, LC3 use 16 bits register. So every time that you see R0, R1, R7, R5, etc., think of it like a file, okay? It's a storage location that is 16-bit, and you can use it as addressable memory. So it's 2 to the 16. Then we have 8 register from 0 through R7. And out of these registers, some of the registers are in charge of other things. Okay, we can use it for specific things. And in the next few weeks, we're going to dive more into it so you can have better understanding. But for today, we're going to do a Hello World program. And we're going to take a look at the simulator. So I want to give you just dip your toe in the water, some introduction, and so that way we can understand how to write these programs down the line. So these are general purpose register. You can use them for a lot of different things and they are temporary storage. So just keep that in mind. And so when you program in C or C++ at the lower level, registers are handling a lot of these things, especially when you deal with ISA architecture or RISC architecture, okay? So now the instructions are going to be written as 16 bits. And out of that 16 bits, 4 bits are going to be used for opcode. So things like when we say add and load, like LDR or LD or LEA, and I'll explain what the loads are. So it's going to use 4 bits just dedicated for the opcodes. And then the rest, depending on the type of opcode that we're using, it's going to utilize it to either store the actual data like a value, or in our case today, for the first couple program, we are going to use it to loop through a string. Okay, so just think of string as an array of characters. So we're going to loop through the characters to really display that on console. And LEA is a little bit different than the other loads, so I'll touch on that. So here, it talks a little bit about how it does support with keyboard, monitor, and at the low level, we can write instructions for our display to see. We can see a certain character on the display. We can let it listen to the keyboard, so that way when a user strike a key for input, it's going to be able to record that. So down the line, we're gonna think about how we're gonna use input. Now, for all data, it's gonna be stored in the 2 complement presentation. There's no separate support for unsigned arithmetic, meaning that when you're dealing with a negative decimal value, make sure that you treat it with 2's complement. Remember, we did that last week. Like I said, we only add, right, the 2's complement of that value. So it doesn't understand a negative sign unless you put it into 2's complement. Now, in the simulator, coming back to this a little bit, our simulator are not gonna allow you to directly program the keyboard or the mouse itself, but we're going to write the program for the computer to display something, to operate, to calculate something so we can see. And keep in mind that we're using ASCII characters. It's ASCII encoded. So the text that you see is in ASCII characters. So in program number 3 and forward, it's best for you to look at an ASCII table and to be able to really see the value that it's being stored or loaded or used in that program. Okay? It does not support floating point numbers, so we do not use like $1.99 in our program. It's not simple like that, right? So it only sees everything as ASCII character. Unlike C++, where you can say int and different type, right? This is a very much lower level, so you have to treat it as in you have to set everything up and make sure that there's memory allocation for different type of data that you're going to work with, okay? So with that said, let's talk about some opcodes, okay? So in the program, you're going to see ORIG, that's origination. And this is always going to be at the beginning of all assembly program, not just LC3. And you want it to originate at an address. So we're going to use hexadecimal for our address, okay? So you're going to tell the program always where it's going to start. And for LC3, we will start at hex 3000. Okay, so that's the first line in your LC3 program always. Okay, now just like how in C++ you would have, uh, include certain library, for LC3 we're going to start with the origination address. That's where it's going to set up. At the end of your program, you must have .n. Do not forget the period with these opcodes because it's going to throw an error. Okay. At the end of your program, you can use .n. That's kind of like return 0 in C++. It's finished. Okay. So we're going to end the program with .n. And the BLKW it stands for block word. Okay. And each word is 16 bits. So when do we use this? We use this to set up an array of addresses so that way you can store, larger values or larger strings. Okay, so think about that, and we're going to come back to this. And when you use LC3 for your project, you're going to revisit this again. So every week we're going to work on this. And we wanted to give it a value in the operand. Okay, so the n here indicates just a number that we wanted to assign to it. Think about how you create an array in C++, right? Sometimes you would say, this is my array called my array. And then inside the square brace, you would put, the number of indices that you wanted to use, right? 5, 10, 20. So we wanted to give it a value so it would set up a block for us. And that's going to allow us to allocate a larger group of memory addresses for specific things. We want to fill, right? Fill is another way that we can add data to a certain location, and it's often used with an array, a group of memory addresses. So you can allocate one word, initialize it, add a value n. Okay, so we'll practice some of the fill. And then anytime that you're using strings, you have to use the dot strings with the Z. And this is going to be whatever text character, and you need to put it in quotation mark. Okay. So it's because it's null terminated, like what you've seen in C-based language, you have to make sure that you allocate, it's going to allocate an n plus 1. So however many number of characters that you're going to use, it's going to do a +1 character at the end for null terminated. Okay. So that kind of give you a very brief overview on opcode and operand. Okay, so let's take a look at the format. So this is the way that we are going to structure our lines. Okay. Anytime that you use a label, that needs to go in the front. And label is used in many languages. So it's a way that we can move back and forth. We can identify an area of our program, right? And then have it process something, and then we can go back and forth. We can jump back and forth using label. So label is just an identifier. It allows you to section your code. So if you're using a label, like today in the first Hello World program, it uses HW, then that will be a label. Okay. Now, if you don't use a label, that doesn't need to go to the front. You can start with the opcode right away. So this is optional. The opcode, like what I mentioned before, those will be instructions, and sometimes they would start with the dot. Sometimes we would straight use opcode like add and not, right? Things like that. Okay. Opcode is mandatory. It will throw an error if it doesn't understand or if you have a typo. Okay. The operand is what needs to be followed, like register, okay? And you would separate register with a comma. So we'll talk about source and destination registers, okay? Anytime that you want to comment, you would use a semicolon. So if you start with the semicolon, it's going to ignore that line because it knows that it's you using a comment, okay? So add code, like we said, those are LC3 instructions. You can have or, not, and registers is 0 through 7. Anytime you're using a decimal number or base 10 number or ternary, right? You need to start it with a hashtag, okay? Anytime that you're using a hexadecimal number, you need to start it with an X. Okay, and LC3 is not case sensitive. So the only time that you see it's case sensitive is when you use it in string. But in our case, what we see is we are, you can type your opcode in all uppercases. That will be fine. It'll understand it. I tend to do that because most LC3 program that you see, everything is in uppercases or capital letters. Okay, that's common practice. The labels, like I said, it needs to be at the beginning of the line, and that's just a symbolic name, and we use that to move back and forth. So the example that you see right here, okay? So what we have here is the opcode, and the first register here is a destination register where you want it to go to, okay? So in this line, as you read my comment, it adds whatever value in register 1 to the value of register 0, okay? And then it's going to put the result in the register 0, okay? And you can reuse register this way because there's only 8 that we can have in LC3, okay? So we first would have an opcode, and then we would have a destination register. And then whatever that would follow is the source registers. Sometime you would be able to put in values like this. So if you want to initialize 5 as decimal, right, to register 0, this is what you do. You would do an add R0, and then you point to R0 to store, and then you would take R0, assuming that we initialize R0 at 0, right? So 0 plus 5 is going to give us 5. and it's going to put it in the R0 again. So it's going to update that register with a decimal 5. Okay. Any question? Okay.
Wait, I got confused. So you said
Mhm.
when you put add R0, that stores R0 in the register,
Mhm.
and
So
then
it's like this, like you have a variable 0, right? And then you say it's going to be equal to itself plus 5.
okay, I got you. But the part where it says add R0 comma R0, that's how you code that.
Yes.
Oh, okay, got it.
Yeah. So what it does is, if let's say that the R0 is 0, right? We assume, and I don't like to make the assumption because you never know. Sometimes there might be something in that register still. So I will show you next week on how to clear out register. Okay. Like we clear it out, initialize it at 0, and then we add 5 to it. So this line simply is like saying that we take whatever that's in 0 plus a 5 and then put it back into that register.
So the new register would be var0 plus 5.
Yeah.
Oh, okay.
Whatever the value in var0 to start with, right? Whatever the value in register 0 to start with. This is just an example that I would see, you would see in like C++, right? But this right here is you are only going to use register, okay? I have a question. It says if we like 3 values to add, would it still be the same format? You have to repeat it 3 times, okay? So you have to add, so let's say, that's a good question. Let's say that I need to add 5, 6, and 7, right? It tells us to add 3 values. So you would do an add R0, R0, and then a hash 5, okay? That's going to be the first number. So what happens is at this point, R0 is equal to decimal 5. You see what I mean? And then the next line, you're going to do an add R0, R0, and a 6. So at this point, R0 is equal to 5 plus 6, which is 11. And then you would continue with 7. And is there any question? You guys okay with this?
Sounds
So
really
far.
tedious.
Yes?
So then in the case like for, oh, sorry.
Uh-huh. Go ahead.
If there was something like if we had a equation that we needed to do and there's like
Line by
multiplication.
line.
Oh, wow. Okay, thank
Yep.
you.
Somebody created the compiler for you, right? People created the compiler for you. You should be thankful for that.
Extremely
So
thankful. I don't like math.
yeah, so now when you look at Java and C++, it's a different lens because the compiler, and it takes that and it translates everything, but somebody programmed those instructions into the processor for you, right? The engineer and the developer, they did that for you. So when you simply operate algorithm, right? You use an algorithm in your C++ or Java program, you see now that like it's tedious, but somebody did this, right? Somebody, and they're still doing it. So when you use your smartphone next time, think about all the details that needs to go into it and be able to do that. Now we have machines that streamline some of the process, but people have done this from day one. So all right, are we good? Okay, so that kind of give you an example if we need to add 5, 6, 7, 8, 9, 10, and then when you do a loop, it's a little bit more tedious. So as we progress, you will see. Okay, so I'm gonna clear this out because it's just gonna confuse you. So for the next line here, what it's going to do is going to take the A, which is in hexadecimal, and then it's going to add it to R0. So at this point, 5 already was in R0 when we left it with that line. And then it's going to add the hex A. So A is 10 in decimal. So literally, you know, if we look at the decimal value, then that will be 15. But if we're looking at the combined, so and in the simulator, it's going to give you hex value. Okay, it's not going to give you decimal value. The only time that you see the decimal is that it's equivalent to the hex, like 0 through 9. So when it gives you like A6, that's in hexadecimal, or when it's giving you, you know, so that's why we spend some time in the first week to convert these things so you know what they mean. So when you check your values in the future, you can use your computer calculator and check it, because the simulator itself is a calculator and we want to make sure that it loads and output the right result. If it didn't, somewhere in your code, your operands and your opcode is wrong. So when we do things like Fibonacci and things like that, right, it should output the right sequence. So when we don't see the right sequence, something is funky in the code. Okay. All right. So I will come back to this in the lecture in the future and the lab, and I will walk you through it. We'll do stuff together and it will make more sense. So in the next part is going to be pseudo instruction. So when we say pseudo instruction, it encompasses, you know, a number of instructions within. So when you wanted to stop a program, you would do a halt. And we often do this at the end, right? Sometime we would do it with a loop. So that way it would take the processor into the next stage. And then in the back, we will learn about trap. So it's when you see the simulator, it's going to show trap and a value. And these traps are assigned different value for different purposes. Okay. So, and on the final in the future and the quizzes, I ask about trap when we talk about trap down the line. But trap 25 is going to stop and it's going to print the message that it stops. Okay. It halts. And then when you wanted to record input, most assembly that doesn't use a C compiler will record one character at a time. Okay. Do not try to, because it's very simple. If you write assembly language that uses a C compiler, you can treat it like how you would write C++ or Java, right? Then you're able to do a lot more to it. You can use string object with that. But when you're using assembly like LC-3, it's going to record one at a time. So what happens is when you have the user input like hi, HI, it's going to take each character and it's going to convert that to a value, and you have to store each character value to a register. Understand? So when I issue like a string like this, so in C++, we would say like my string is equal to, right? And we would say like hi, like this. Okay. What will happen is in an LC3, you have to take the H and you need to load it to a register. And then we got to move each of the character to memory location in order for it to store. And then that in that sense, we have to use a block word or an array to be able to load that. And you can loop through it, the whole string, to be able to store it. So when you have an input in the future, make sure you think about that. It needs to first, okay, it needs to convert string from character from ASCII to numbers, okay? Then store, okay? And if you manually think about that, then it's a lot easier for you to write each of the following line after you ask the user to input something, okay? You have to take it and move it somewhere and store it so that way you can reuse it later. You know, like how you would set up a variable. Well, now you have to say where, you know, where that variable is and how it's storing it, okay? All right. The output is where we would write one character to the console. So today, when you see hello world, it's doing one character in the time in the each time in the back. So it's going to take that string and it's going to convert, right, each of those and show it to you in the console from the register. And because we're only having 16-bit, when you're using a larger string, think about how it might overflow. Okay. All right. So when we do an out for the pseudo instruction, that's just going to show the character onto the console. Now, the difference between out and puts, okay, out does one character at a time. Puts will put a whole, the string that you assigned it, okay? So today when we use put, it's because we have a string, but if you need to show only one character, you just simply do an out, okay? And then get C is just get the character from the keyboard. So when you're doing a get C, it's gonna read one character at a time, okay? So for the in, it's gonna print prompt in the console, echo one character from the keyboard. So we normally would have the user input by doing a get C and an in. Okay, I will show you some program that does that. Any question? Okay, no question, huh? Maybe save it for later. Okay, all right. So the download is here. I also put in your LC-3 resources page. Yeah, so when you do a CIN in C++, yes. But when you do a CIN, right, it stores everything that the user typed. Okay? But in the back, it's really, you know, taking the character, converting it, storing the value in binary, and then converted it back when you have a C out. Right? So we are doing the job of the compiler in assembly in this class, so you can understand. And if you understand this, you know, all the other stuff is easy. So, all right. It's gonna be fun. You're gonna get it. Okay. Okay. Okay, so when I visit the site, let me do control click here and see if come on. So you will, this is only for Windows, okay? If you're using a Mac OS right now, okay, you can find the first module and click on LC3 resources. If you go down, there's an online simulator that I link. You will need to use that for this class. Okay, it looks similar, but it's not exactly like how the interface of the regular program. You still have the registers, you still have that. So if you're using a Mac OS, right, or if you're using Chromebook, you can just use the online simulator. Okay. Now for the download, this is the website. You're going to download this, okay? And it's going to come down as an executable like this, okay? So when you try to open it, it's going to ask you to unzip. You need to unzip. Okay. If you don't have, you can use like 7-zip or other program, but if you don't have anything for the Windows environment, you can just simply use unzip. You need to unzip it. Okay. I already have it, so it's not going to let me, but I'll show you. Okay. After that, you're going to go to your C drive. So this PC and then C drive. And then there's a folder that's called LC-3. And that's where the program is. Okay. When you write your code, you are going to use the editor. When you're done with your code, you're going to have to assemble and simulate, and then you're going to use the second tool, which is to simulate. Okay, so I will illustrate this when we write the first program. Okay, so unzip for those of you who are using PC and downloaded. And then once it unzip, find it in the C drive. It's going to default it there unless you browse and set it somewhere. You can create a shortcut for your desktop to go to that, or it's always going to default to the C drive if you don't change the directory or the folder path. Okay.
And then after?
Now we write. So open LC3 edit. Okay. Now, if you wanted to put it on USB, you can take that whole folder and put it on USB, and the program exists on your USB. You can store it wherever. It's really small. It's not that big. If you look at the size, tiny. Okay.
Oh, and you can save it on LC3 too, the code?
Yep.
Oh, okay.
Okay. All right. So open up your LC3 editor. I have mine open already.
Oh,
Let
Professor,
me, yes.
if we're using the online simulator, will we press assemble to get to the editor?
No, hold on one second.
Okay.
No, you only press assemble when you're done with the program. Let me see where it's set all register. So if you need to reset, like for the LC3 program, it has a button called reinitialize the machine. After each program, you need to reset it. Okay, you should reset it so it clears things out. Let me see where you can find this. Jump to manage label. Let me check out his GitHub.
Wait, which one's easier to use, Professor? The one you're on, the browser one, or the downloaded one?
I'm gonna simulate. I'm gonna show you in the regular editor. The people who are using the Mac OS, they have, because there's no release for it under Mac OS. There is one release for Linux. So if you're trying to use Linux, you can, but you know, let me see where you can. Yeah, this is just gonna be assemble. Okay. Oh, yeah, here. You're right. Click assemble and then you can paste your code in here. You can write it and then you would assemble. So it builds the ASM directly for you. Okay. So for those of you who are using the online one, you're going to click the assemble and then you would write your code in here. But I recommend that you use a text editor on your computer, save it as a .asm, so that way you don't lose your file, because when you submit that, right, it's just gonna assemble it for you. And so after you're done, you just click the assemble button to check your code. Okay. And you can use Nano, if you have Nano on Mac, or if you use Sublime editor, you can use any text editor to write any program really. You don't need fancy IDE for stuff. Like I don't really use a lot of the IDE that way because IDE is restricted to the things that's on there. Okay.
You said save it as what?
.asm. So I'll walk you through that now. Okay.
Okay.
All right. So let's talk about the next part. Okay. So we got our simulator going. And those of you who are using the online one, you can click assemble and you can paste your code in there, but use the text editor to write your code and save it as a name.asm. So let's talk about number 6. Okay. Here is a program. Originally, this is lab number 3, but I move it up. So now you're doing it in lab 2. So this is a Hello World program. At the top, everything is comment. Okay. At university level, I'm going to tell you that they want you to comment like this. Okay. Like your course name, your name, this. And then in most program, when you write for other developer, you need to tell it, you need to comment like what type of input you're expecting, what kind of output you're expecting, and what kind of side effects you're expecting. Okay. And you don't have to be wordy, you can just simplify it. And then in this one, I include the run. So assemble the program, how to run it. So once you're done, you need to save it as a name with the .asm extension, right? Like just how the screen capture you see at the blue. So all assembly program is saved as .asm, okay? Whether you write it in Microsoft ASM or LC-3 or, ARM, it's .asm. Then what happens is different assembly language is going to use different tool to build the program. And we're using a simulator to be able to see our program. So when you do that, then it's going to create object file, binary file, and hex file. So that way you can see, and we use the object file to simulate. Okay, and that explains it in the lab. So in this program, you start out with hex 3000, right? So we have a dot origination and the address. Okay, so for LC3, it starts right here. And then the LEA it stands for load effective address. This is not used to load data, okay? This is often used to load something with a label. Like you would have a label store something, okay? And then you're gonna load that label to the register. So what it's doing, it's gonna load the address of the label to the register. Okay, so at this line right here, you're loading the address of HW to register 0. Okay, and then we're gonna do a put. So put is gonna let you see the display of your string, and then we're gonna stop it, which is where we do a halt. But the label is gonna be on the bottom. So here we would have a label called HW, stands for Hello World. And this label is going to have strings. And then for the string and declaration, so basically you're declaring what HW is, it's a string, and you use double quotation mark for your string. Okay. And then that will be the end of our program, so we do a .n. Okay. Are we clear on this? Any question with this?
LEA means that it's loading in the register, right?
Load address.
Oh, load address.
I have a comment here.
Yeah.
The semicolon is the comment. It loads the address of HW to the register 0.
So HW is like our variable, right?
It's a label.
Label. Gotcha.
Yeah. So, and LEA only uses register 0. Okay. If you try to use it with another register, it's not going to like it. We can use other load with other registers. So there are 3 types of load, and we will cover that in the future chapters. Okay. So question. All right. So here I explain it. So make sure you look at this section if you're not clear, right? I put down what each line does. Okay. So after you create the program, you should save it. So I have you save it as hello world.asm. So here is my program. I know it's small, but here's my program. Okay. And I have my comments at the top, like what it shows in the screen capture, the program that I wrote. Okay. And in the example on your lab, I didn't tab everything, but on this I tab it. So that way it lines up a little cleaner. Okay, so here are all my comments. And you don't have to comment every line. We're only doing this because we're learning. We're a beginner at this. Okay. Then when you're done, you're going to go File, Save As. And I have it in my Unit 2 folder. So you can call this hello world.asm. Okay. Click Save. Don't forget the .asm. I will show you how you can get those files. Just give me a minute. Okay. So you should keep those files. Don't delete them. All right. When you're done saving, you're going to click Translate and Assemble. So for those of you who are using the online simulator, paste your code in there and click Assemble. Okay. So Translate, Assemble. So on the bottom, you're going to see the messages of what happened. If you get an error because you have syntax error, it's going to tell you the errors. Okay. Now later on, when you have a bigger program, right, it's going to tell you which line it is, but our simulator, our editor doesn't have the line, so you have to go look for it. Okay. So it's not exactly the friendliest tool that you're going to use, but you will learn assembly this way. Okay. And many university students like yourself, college students, have learned this. So, and they're still using LC-3. So if you get 2 errors or whatever, go look at what you type wrong. Okay. Is it line or address space? I don't understand your question. Oh, as in the error, it's line. Sometimes it will tell you line, and sometimes it usually tells you what line you have as error. Okay, so for memory offset.
Hey, Professor.
Uh-huh.
I noticed that you put a space like in between like the lab 2, like you're skipping lines, right?
That's
If
fine.
you weren't to skip a line and then you put the semicolon, would it still register that hello world program or whatever phrase it's voided or no?
Yeah, so
you know what I'm
anytime that
saying?
you see a semicolon, it's gonna skip it. Okay.
Okay.
Yeah, it's a comment.
All right. So if I were to put like just like let's void everything and let's just put like picture the lab 2, right? You see how you have the semicolon right there with the lab 2? Let's
Yeah.
say I skip a line, right? And then I write the hello world program, but I don't put the semicolon. Would the hello world program still be voided as well? Or
No. Yeah,
oh,
if you
okay.
don't put the semicolon in the front, it's not going to treat it as a comment, and comment is ignored by the simulator.
Oh, okay, I see. So
Yeah.
it's based on the lines, right?
Right.
But if you were to have lab 2 hello world program on the same line, then that would be voided.
Yes.
Okay, I get what you're saying.
So for those of you who are looking for the online simulator, in the first module of my Canvas course, you will find LC3 resource page, and the link is provided under online simulator. Yes, all my videos are recorded and it's on my YouTube channel as well, and I link it to the class module every time. Okay. Is there a way to have LC3 simulator have the line count on the side? No, if you're using the LC3 editor, it doesn't have the line count. But if you use a text editor, right, you can use any text editor to write it. You just have to save it as a .asm. So Beethoven, if you're using Atom, you can use its text editor to, and then save that file as a .asm. Okay, but you cannot assemble it until you reopen that file in the LC3 editor. Understand? You can use Notepad++. You can use any editor. And Ernesto, it's the first link. Okay. Sure. So, okay, I see a lot of questions about using editor. You guys should not have to worry about this. Let's say I use Notepad. Okay. I write my program here, right? Then I save it. Make sure that I save it as a .asm. Okay. Then I would go to my LC3 editor, open it up, find the file, okay, that I save it as a .asm, okay, then assemble. Understand? So if you're using another editor because you wanted to look at the line count, the number, then save it, then you still have to use LC3 editor to assemble because to translate, because in your regular editor it doesn't have that. Okay.
And with other editors, you can have stuff like syntax highlighting and stuff.
Sometimes if it has the appropriate library, okay? And LC3, for all the classes that I know that teaching this, they use, you know, their customized simulator or the simulator. This has been used for a long time because, you know, there are some stuff that's floating around online, like your online, you know, assembler, but you know, if you're using a different text editor, the process is you have that extra step to reopen that program in the LC3 editor to assemble, because you don't have this option in your regular IDE. Okay. LC3 has syntax that, yeah, well, okay. I don't think so, unless you can find the debug library for syntax highlighting. Okay. Because it's built for C and Java, so you might not have all of that, or Python or a C-based language. Okay, so when you program with like ASM64, you will be able to use C compiler, but for this one you can't. All right, so here's my first program. I assemble, and then what do I do next, right? Then you're gonna open up your simulator, okay? And then you are going to, here's your simulator, okay? Let's talk about this real quick. Anytime that you load a program, right? Let's say I load the first program and then I'm getting ready to load the second program, reinitialize your machine. It's kind of like rebooting your computer. So when you reboot the computer, technically there are values here, but in the simulator, it zeroes out everything. Okay, so it's just kind of clear everything out. Then, so when you first open it, it looks like this. Okay, but if it has value, just reinitialize machine. Okay, then you're gonna open the file. You're gonna find your Hello World program. Okay, so when you assemble the program, this is what's happening in the back. I'm gonna go to my folder so you can see. So here's my ASM program, right? When you assemble it, it creates the bin, the hex, okay, and the list, the sim, and an object file. It's hello world.obj. You see the 3D object right here? So when you click that assemble button, what it does, it creates all of these files, okay? And the simulator uses the object file to simulate the program for you, okay? Similar to what we've seen in other languages, but in this case, it comes with additional file, and the bin file is only going to show you binary. So if you're curious about what the computer sees in binary, you can open the bin file, okay? But when you simulate, you have to use the object file, okay? So it creates these bin, hex, and so forth. So keep those files because those files are associated with the assemble file for your .asm.
So if you had an actual LC-3 processor on you, then you'd use the bin.
Mm-hmm. You can still use the bin with the simulator. Sure, you can look at it. You can use the hex. That's why it's there for you to see. Okay. All right. So going back to this, when I find my file, I'm going to click on the object file and I'm going to open. Make sure that's obj, right? Open. And then what we're going to do is we're going to click this run program, which is the one with the green arrow, or you can do an execute and a run or an F5. Okay. So when I run this program, if your console is hiding, it's a separate window. Okay. And that's the program. That's the output that you see. You see that? Hello world. This is my first LC3 program. Yes, you have to create it yourself. So Ernesto, once again, we're going to write it in a text editor because you're using an online assembler. You are going to, after you write it like the exercise asks you to, you are going to paste it into the online simulator and you're going to click assemble, and then it's going to show you something in the console. Okay? Any other questions? I see some questions popping up. You're able to save a specific file. Okay.
Oh, Professor.
Mm-hmm.
So when we turn in our lab, are you looking for what we type in the editor, or
I need
what you're
to
looking
see output and input. I need to see
Got
your
it.
code and your output. So screenshot them to, you can put them together and screenshot it.
Got it.
Okay. All right.
Hey, Professor, do you mind showing your code again? Because I got errors on mine.
You can look at your lab document. The code is exactly like the lab document. It should be.
That's what I was following. Maybe I just typed it wrong.
Check every line.
And make sure you put the decimal or the period.
Yes. Like the .n, make sure it's .n, .or, .origination. Don't forget the period because it's gonna go funky if you forget that. Because it doesn't know without the dot, it doesn't know that it is an instruction. Okay. All right. We spent a lot of time on this and talking about what happened in the back, but I wanted to touch on the simulator. Okay. So let's, I'm going to reload the program. Okay. So initially, when you tell it to have origination at 3000, it's here. You see that? When you load the program, it starts there. So at this address, you see all your instruction. So when you do a put, you see how it puts the trap, and this is the trap number right here. Okay, 22 is for the put. When it halts, it's going to do a 25. Here's your label, HW. Okay. And so what it's doing is going to load the effective address. So it's going to take the address of the HW, which is hex 3003 here, and it's gonna load it into the register 0, which is here. Okay. Now we won't see anything happening here until we run it. But a good way that you can check every single step is to use these buttons up here. You can do a step into, a step out, and a step over. And for those of you who did the tutorial, you saw this. Okay, I added a tutorial for you to kind of prepare yourself and look at how. So when you do this program, you kind of have to see how the computer goes through each process in that, right? So you can do a step over, or if I wanted to do a step into, right? And then if you wanted to stop or put a breakpoint, you can put a breakpoint in certain area. Okay. And on the LC-3 page, this one I added some video. This one is done by a TA that teaches at a university, and he explains it a little bit on how to use it. And then this one is on like some of the later instruction that we talk about. So if you're not sure how to use it, check out this video later on. Okay, he walks you through because he explains it to his class, and so you can take a look at that. Okay, so if you wanted to slow down the process, so when I click run, you notice that it brings you here. So at the end of the program, look at the address where we end up, right? Because and the data is changed, okay, inside the register as it loaded the string, and it loads the address from the string it shows you. So we'll talk about PC, IR, and some of this down the line. Okay, so I want you to take a look at that, and then, you know, because it's pseudo instruction for some of them, it has some of the additional opcode that's added there. Okay. All right, let's do the second program. So on the second program, I asked you to look at the first program, and you are going to create a similar program to that for number 14. Okay. So in this case, we're going to have two strings. We're going to have one that says this is my second program, and the second string we're going to have I'm learning assembly program. So how do we do this? I make it a very large string and combine those two sentences together? No, it's going to overflow. Okay. What do I do? What do you think I should do?
Use two strings.
Two labels. Yes, two strings, two labels. And then do I do anything else at the top? How is it going to show two strings? How is it going to show two strings?
Do you have to set two labels?
Two labels for two strings. And then what? If I only do a one put, it's only going to put one string. Don't I have to do two puts?
Yeah.
Yes. Okay, you're getting it now. So here's my second program. Again, I originate at 3000. Okay. I have an LEA of 0 to 0 with the HW. Okay. So I'm just reusing stuff from the first program. Then I show it on console. Then I reload the R0 with a different address, which is the HW2. Okay. At this point, it's going to take the second string and it's going to put it into register 0. And then it's going to put, and then I halt, and I end. And down here, I declare 2 strings. And you can use the new line carriage that works in LC3, so that way it's clean. Otherwise, it's just going to be one long sentence, right? One long line. So when I'm done, I translate, assemble, no error. Okay. Then I go to my simulator. I reinitialize my machine. I load the file. So click File, Load Program. I find my second exercise. Okay, look at it, make sure. So it has 2 LEA, it's going to do 2 put, and it's going to halt. Start at 3000. Then I can execute it. And then I will look at my console. See, my second program, and I'm learning assembly. You can name your label anything you want that makes sense to the program. Okay. Try to be conscious about, what your program objective is. You're the programmer. You can name it something that makes sense to you in the program. That's fine. Yes, LEA, R0, and you have to use R0 if you're using LEA. Okay.
Yeah, I figured why my program wasn't running. It's because for the R0 I had RO, and so
Yes.
it wouldn't work.
Typo. Okay. Any question? You don't need to halt. So I just, at the end is where we halt, right? Because if you halt and then re-halt, it doesn't require that because you wanted to put and then halt. Okay. Halt would be used like in some cases where you have a loop and you wanted for it to stop, you can stop it and then go to the next part of your code. So what it does is it's going to trap it and then it's going to move to the next part. So later on in this class, we're going to write a stack with this. So I hope that you learn how to write stack in other languages already so you understand, but we will write a stack with this. Okay. We're good? Any question? All right. So those are the 2. So if you have a lot of different strings, right? You just have to keep reloading it. LEAR0, LEAR0 puts, LEAR0 puts. So when you're prompting the user, like, enter your name, you have to do that LEA and then the put. And then you have to also record what their input, right? Get C. But remember, get C uses 1 character. Okay.
So the \n is similar to C++, right? Where it skips the line.
That's a new line.
Oh, okay.
All right. Doing good, right? 7 o'clock and you got your 2 assembly program running. Let's talk about the next one. So, all right. So while some of you are still working on that, I'm just going to go through this and touch on this a little bit. So when you add two integers, it's done using an add instruction, add opcode, right? Like this example. The content of the register R1 and R2 are added as the result and place it in R3. Okay. Note that the values of the integer can be negative as well, since there are 2's complement of the format. Add also comes in immediate version, where the second operand can be a constant integer. Okay, so we can add 4 to register 1 and place the result in register 3. Okay, so, and the constant of the limit to 5 bits 2's complement format. So when you look at this listing, you have 2 register. So the destination is R3. So it's like this, okay? It's like saying that variable 3 is equal to var1 plus var2, like this, right? That's the first line. So what it does is R3 is going to store the result from adding 1 and 2. Okay. And then on line 4, R3 is going to store the result. So when we left here, it's already stored the result from R1 and R2. And then on the next line, it's going to take that and it's also going to add that to R1 and 4. So 1 plus 4 is going to also store into R3. Okay. So it's like this. var 3 is equal to, right, again, var 1 plus 4, which is decimal 4. Now, for number 6, when you're adding a negative constant, this can only be used with a constant, and you have to add the negative to get a subtraction. Okay, so at this point, it's gonna take R3 and it's gonna store 1 minus 4, like what the lines show here. And it's going to keep on retaining all the values from the previous line as well. Don't forget that. R3 is going to store everything from line 2, line 4, and at line 6, it's going to take all of the value combined from the other 2 lines, and it's going to also store R1 minus 4. And then on line 8, R1 is going to be R1 plus R1 itself, right? Like remember how you can do that in C++? It's exactly like that. So we're just going to take R1 plus R1 is equal to R1. Okay, like we would do an increment. Question. All right, so let's look at the next program. Sorry, I didn't want to delete all my stuff there. Okay, so on the next part, it talks about the arithmetic logic unit, which is ALU. The same register can serve both as source operand and destination in register. So we can we can reuse the register by just updating it, right? Like it can use as a storage. We can use it as to do a source and destination to add. Okay. Okay. For 15. this is a program that is going to output a hex number. Okay, remember this is a hex number. And so when we look at this program, this is how you clear a register, okay, after the origination address. So, and I tell my student every semester, do not assume that it's cleared to start. You never know, right? Because in realistically, in a regular computer, when you start it, it already has some value somewhere, okay? It could be your startup programs and whatnot. So it's always a good practice to clear out the register that you're using. Okay, so at this line right here, when you're doing an AND, R0 with the 0, remember when we talked about the AND rule, anytime that you AND the 0 with anything, it's going to be a 0. So this is why you AND it here. Okay. Then if you wanted to do a load, that means that you would put the data to that register. Okay, so down here I have a label called num, and I fill it with hex 2. Okay, so basically I put hex 2 to a label called num. 2 goes to num, and I'm going to take that. I'm going to bring that, put it into R0. Okay, I'm going to load it to R0. And then I have a second label called Ascii, and I'm going to fill it with 30, hex 30. And I'm going to load it to R2. Then after that, we're going to take it, we're going to take 30 and 2, we're going to add it together, okay, and put it back into R0. And then we're going to output it. And then we're going to halt, okay. So the rest of this stuff down here, this is just the fill for my label, okay. You can even load it with a number. You don't have to load it with a label, but we'll talk about different loads. So LD is you know, generally used to load a label, or you can load it with a number. So we end here, okay, and then we would do a out and then halt, okay. So you try that program and see what you see, okay. Why are we adding 32? Okay. So to understand more about this program, it's best to look at an ASCII table. Okay. Oh, so many ads. All right. Let's look at the offset, or the difference between hexadecimal, let me see, 32, hex 32. Okay. Look at the difference between the hexadecimal and the decimal value. Okay, we cleared the register. We take number, load into number, which is 2, and then we fill the ASCII, the second one with 30. We add them together, we put it back into R0, and then we do an output. Okay, and then we halt, and then we out again, and then we halt again. What do you guys see from that program?
I got 2.
You got 2, but we use hexadecimal. Okay, you see the difference? So if you look at the ASCII table, look at the 2. What is its hexadecimal parallel? 32, right? So how did it get you a 2? Did ASCII convert it? Sure did. Okay. So when you tell it to take hex 32, right, add it and do an out, because the simulator, it knows that it's going to output it to a human. It's going to take that hex value and it's going to convert it to a 2 character ASCII character, so you can see it as a 2. Understand? Because this is a hex value is 32. You said 30 plus 2 is 32 in hex. That 32 is equivalent to a character 2 in ASCII. And when you tell it to out, it's going to show a 2. Okay. So if I wanted to out a number 3, then I just manipulate the hexadecimal value in my register, right? A 30 plus a 3, a 30 plus a 4. Why do I have to do a plus like that? Is because when you fill it with 30, it already fills up that word, right? Because it exceeds that size. So you have to use another fill in order to add those together to convert it to an ASCII.
Wait, Professor. Oh, so when working with numbers, we're using the ASCII chart, right, to like convert those numbers to
Yeah.
the letters and the other numbers.
But in assembly, we use hexadecimal. Okay, so the program that you see here, this is the hexadecimal value. 30 is 30 is a hex and 2 is a hex. So when you add these together, it becomes the 32 hexadecimal, and 32 is equivalent to an ASCII 2. Yes, when you're working with assembly, especially LC3, you have to think about ASCII on how you would, output and input ASCII value as text. Okay, so this is the offset. All right. Anything?
So if we were to print the letters, we just have to find the hexadecimal values of those letters, right?
You're
And then
right.
put it in
So
there.
if I wanted to do an A, what do I need to use? You might have to you might have to use, because as it gets larger in the value, right? You have to think about, it has 16 bits, and it's gonna take 4 bit to already use as for your opcode. So it's left with a certain size bit to be utilized for, we call it immediate value, is when you use decimal or hexadecimal. So if I'm doing like an A, like a 65, I have to think about how that's going to be broken up into different section of the memory. Okay. So good point. So yeah, you can try it and see and play with it and see what you get. Okay, so after you do the program, please answer the questions for me. What is the output of your program? You can type out, what do you see? Explain why the program results in the output from the previous question. I just explained that on how it asks to convert that, right? Describe how when you how you can change your program to output another number, such as a 9. Okay. And then provide the screen capture of the code, the console, and output of your lab for your lab submission.
I suppose technically you could hard code that hexadecimal 3-2 to get the 2 out, but I suppose it's a lot more useful to not use what's essentially a magic number.
Yes. Yes. Because it is an encoded number, it's a number that they use for encoding, and when the computer it decodes that, right? Remember we talked about logic gates this week, right? All of these gates are at work to give you the conversion. Sure, you can hard code anything.
So whenever we try to display a number, we always use the ASCII fill times 30.
You would use the offset between ASCII and hex. Yes.
Got it.
That's what we call an offset. So you would look at the ASCII chart and you
ASCII.
would determine the equivalent of that based on hexadecimal. That helps. Yes. I want to emphasize it this semester because last semester I didn't do it at the beginning, and then they struggle a little bit in the later lab. So if you understand that right down the line when you're doing your course project or other lab where we have to deal with, ASCII, then it seems easier because, you grasp it and you're like, oh, I just manipulate the number to give me this. Okay. Pretty cool though, right? You ever wonder how all of these things work? Compiler. Okay, so on the last one, it's a little longer. Okay, this is another way that you're going to work with ASCII. Okay, so on this one, we are going to do a 2 input. We're going to do a calculation. And I'm going to warn you, okay, there's limitation to this program. It's not perfect. And so it can be better where it might run into giving you the wrong output, but in general it works, and it's okay. It's not the best. So all right, origination at 3000, we're gonna do an in to input an integer as character, so it's gonna trap at 23. Okay. And then, so we're gonna load, okay, the R3 with this label, hex N2, okay, hex N2 0. So what that will do is this label down here, it's gonna subtract, it's gonna be 30. So what we're gonna do is we are going to do a subtraction of 32 because it's an offset to bring us back to where our human 0 would be. Okay, so the second line allows you to load the label. And since this label is not like a string, you can do an LD. And then we're gonna add R3, R0 to R0. So R0 at this point is gonna store whatever that was input from the in, okay? Again, also, I forgot to mention to you, anytime you do an in, it's gonna use R0 because it's the first register. So whatever the input would be, like a number, it's gonna put it in R0 to start, and then we're gonna take the 30 and then we're gonna add it to whatever that was input and put it back into R0. And then we're gonna move the first integer into the register, and this is how you move, you do an add. It's like copying, but I'll talk about copying later. This is like taking whatever the value of R0, and then we are going to put it into another register, okay? So we're gonna move it into R1, And then we're going to take another input. Okay. And then since that input is going to be at register 0, it is going to take that and then it's going to add it to 30 again because we need to convert it. Okay. I'm sorry. Was it 32 or 30? Let me check the label again. Hexen. Yeah, so FFD0. So it's going to add it again. Okay. And then after that, once we have those numbers stored, then we actually, after we put in R0, we're going to move it into register 2. Do you know why I'm moving these values into a different register? What do you think? Why do you think I'm moving them to a different register?
Because when you input integer, it always goes to R0.
Yes. And you want to use that R0 to that register possibly for other things, right? Because if I don't move it into R1, it's going to take the input and it's going to add to it again and it's going to make it wrong, right? So I need to take it and then move it into a different register so I can record another input, okay? Because if I don't, it's going to change the value of my original input. Because we have the input with the offset, so we can have the equivalent in the Ascii. And then, you know, we got to take that and move it somewhere else so we can take another input and then add it with the offset. Okay. So after that, we got to move the second input into a register 2. And then we're going to do a load effective address. We're going to reuse the R0 for that. Right? We got to free up that R0 so we can load it, so we can tell, we can output a string. Okay. So we would do a put, and then our string, we're going to ask them, oh, we're going to show sum of the two numbers. So the two input, it's going to add it, and then it's going to give us the sum. Okay. So when we add it, we're going to take the R0, I'm sorry, R2, and then put it into the R0. First, we subtract the 30. Now we're going to have to add back the 30 to convert it back. So then we can output it. So the process is this: input, add the offset or subtract the offset, convert it to the hexadecimal equivalent, move that out, take another input, subtract the offset, move that to another location, take the move register, the location of the move values, add them together, put it into register 0, add the 32, make it back into Ascii and show the user. Okay. This is just to add two numbers and output. So you can see now how assembly works. Okay. Any question? Okay, so this program, when you do after you're done, you save it as a sum input. And then you load the program, you run, or you assemble, load, and run the program. Okay. Now, when you're testing the program, if you do it with the lower number, like you can do a 2 and 2, it's going to give you 4. But because it's hex, when you get to 9, right, you have to treat it with, because it's a base 16. So, you know, if you test a program with 5, like when you do a 5 plus a 5 is a 10, see if it's going to output the right output there. Okay. What do you think? Any questions, concerns? Don't quit. It's gonna get better. You feel a bit lost. Okay, explain where you lost. In the third program, in the second program?
So there should be like 4 screenshots in total.
Yeah, yes. And answers, please. Make sure you answer the lab. Okay. So going back to answer Dayton's question number 2, okay? In the number 2 program, you should look at an ASCII table. You can find that online, okay? So when you're looking at a hexadecimal 30 here, right? That will be a 2. There is a 30 difference when we're looking at that, right? Between, if you take 30, subtract 2, it's 30 in difference, right? So in the second program, let me go back up. Oh, I think you meant the second program as in output. Is this the one that you're stuck on, the hello world? Oh, the third program as well. Okay, you meant the number 3. That's what I thought. Okay, so in number 3, we see that between 32 in hexadecimal and the ASCII 2 is 30. So in order for us to convert it, because the computer doesn't understand, right? Doesn't understand human text. It only knows binary. And so for us to talk to it, we have to tell it what is this equivalent in hex. So in this program, what you do is you using the register to load the number, or to be able to either load the number and be able to manipulate the offset so that way you can output ASCII text. Okay, so I'm going to walk you through the program again, and so that way you can understand, and we will spend a lot more time talking about registers, okay, step by step. So this is only the first day. Next week, we're going to redo this again in a different way. Okay, we clear out a register, and when you use the AND operator, anytime that you AND with the 0, it zero out everything, okay? And if you're not sure about this, going back to the assignments from last week and the notes, or even, yeah, last week we did the operands with the AND, okay? So when we AND it, we clear it out. Then we have a label. Think of a label like what some of the students said earlier, that might be a variable, right? So it's just an identified area. So here is my num, and I fill it with a hexadecimal 2. Okay, so when I fill it with a 2, I can load that 2 to register 0. Okay, so basically the register 0 is going to store hexadecimal 2. Then I'm going to load the second one with the ASCII label, which is filled at 30. It's like using pointer in C++. You point to the location that stores the value, okay? So you're gonna load it, and then that label stores a 30, so it's gonna put the hex 30 in here. Then you're gonna add them together to make it a 32, right? So if I take a 30 plus a 2, that's a hex 32. So that when we add it, that's going to give me a 32. And when you have it out, it's going to take the hexadecimal 32 and it's going to convert it into ASCII, because the simulator is designed to display it for human, and human sees ASCII value. And you can check by looking at this, okay? Hexadecimal 32 is going to give you a character 2. So you see a character 2 because there's a hexadecimal 32. So, and then if in the next program, it's the same concept using the hexadecimal manipulation. So in the next program, what we're doing is, okay, so we have an input of number, okay? Then we are going to subtract 30 because we remember that it's going to be 30 offset, right? Any for the character, if you're looking at the ASCII character, right here, if it's a 1, it's a 31. If it's a 2, it's a 32. There's a 30 difference between the character, between the character and the ASCII. So we utilize that. So we first are gonna subtract it because the input it's gonna be lower than 30, right? So if I want a 1, I need to subtract 31 from 30 from 31. If I want a 2, I need to take 32 and subtract 30, right? So we start with taking the input, we subtract it to the 30 so we can convert it. So that way the computer knows that that is the hex equivalent for the value. Then when we're done, before we output it, we got to add it back so it converts it back into ASCII for us and show the sum, okay? So here is where you subtract 30 so that way you can get the offset. Then after each of the input, after you convert it, you got to move it into a different register because you're going to reuse register 0 for another input. Okay, you cannot leave it in register 0 because if you do, it's going to give you the wrong value. Okay, then question?
Yeah, I was gonna ask. So the hex N20, that N means it's negative, right? Or
Yeah, it's just a label. You can call it any label, but what I use that label for the fact that it shows that we are subtracting. We're subtracting for negative. Okay, we're subtracting from the offset because you saw 32 subtract 30 is going to give you 2, right? So if we subtract it, we're going to convert that input into the hex equivalent.
oh, so it's actually N20, like that whole thing is the
Mhm.
negative or whatever. Okay, I got it.
Yeah, you can name it any label. The label, you can name it anything you want as long as you know what it's doing, right? What it's storing. Okay.
So yeah, labels are essentially like constants in C++.
Label is label in C++. Label is, you can make it, you can store constant, yes. But label is also used as label in C++ and Java. You can use label in C++. So it's just you can identify it for anything. And in this case, we use a label that's associated with an address that's going to store something. So it's like a variable or any container, really. It is a container. Okay. But you can store constant. Yes, Ryan, you're right. Mhm. Okay, so after we move it, we use R0 to do our string message. We're going to show that. And then we're going to add it to get the sum now. Okay. After we get the sum, we got to convert it back from hexadecimal to our ASCII so we can display it. So it's about switching back and forth between ASCII and the computer value, which is hexadecimal, and then taking that, convert it back into ASCII. So we humans see ASCII, the computer sees hexadecimal or binary. So when you tested, did you guys get the right sum? Anyone? Okay, good. If you test it with a larger value, keep in mind that it's hexadecimal, so you can use your calculator to check. Like I said, there's limitation with this program, so it's going to reach a limit because we're using a word that's 16-bit. So eventually, if you test it with a very large number, it's going to fill it up and it's not going to be able to store a large number. So in the sense where if we want to scale this program out, we have to think about how we would allocate the memory for the sum. Okay.
So for 23, are we going to test numbers bigger than 5 until we get like errors or?
Yeah, so I see that some of you put in the chat that when you get above 9, it doesn't give any output because it reaches the limitation for the storage. If it has something, but it's not able to convert it for you. But also, you know, ASCII also have limitation too. So you know, we can fix this program to give you something that's above 9. So if you do like a larger number, and again, you guys cannot think about decimal in this class. It's hexadecimal you're using, and hex is a base 16, 0 through 9 and A through F. So when you add a 5 with a 6, that's 11 in decimal, but what is it in hexadecimal? Okay. Anything over 9 doesn't give you anything because it's over its limit. So because it's not converting it back accordingly. Okay. So think about how you would fix it. So the main purpose of what I'm doing in this lab with you is to introduce you to how to use string in assembly and how to use some of the opcode in assembly, how to use register in assembly, at least the beginning, okay? And how to work with ASCII for the last 2 exercises. So weeks from now, I don't want to say, I don't want you to hear you say, Dr. Nguyen, I don't know how to output a string for my project. I don't know how to, because we've done this, right? So go back and redo the lab, and so you can see. Okay. All right. Make sure we answer the question, describe your output, explain the reason of such output. If you run into error, what could possibly go wrong to give you that error? Why is it not showing anything above 9? Think about it logically, right? This is math, right? There's location. Think about the programming concept behind it. If you allocated a certain size, and when you reach that, is there something in the conversion, or is there something in the memory that's going to make it create a limitation in this program?
After character 9 in ASCII, it goes to punctuation marks like colon and semicolon.
Yes, because, and then go back to your ASCII. What is this, right? Is it converting it right? If you do a certain hex value, add the larger number, right? And remember, ASCII only goes up to 127. So. Okay. Do you have any other questions for me? Something I did not address, because sometimes when people type in a lot of different chat, responses. I might have missed something, so please let me know. You can verbally tell me. Okay, so screenshots and you know, you can include the questions. If you want to submit this document, you can add the screenshot under each of the question. That's fine. Make sure you save yourself a copy so that way in the future, if you need to reference it, you can. Okay. Wasn't it fun?
So from what I know, like ASCII is the simplest of the character encodings.
Yes.
So it only has a small subset of symbols we use, like.
Yes.
And then there's Unicode, which has everything else, like all other languages and emojis and such.
Yes. So in this class, when we're using ASCII, and ASCII, like I said, there's limitation with ASCII, right? If you look at the end of the table, it's only going to go up to 127 decimal, and that's the end. So yeah, you don't have all the additional characters and things that's outside of what is set. Okay. Confusing to begin with.
It's definitely very confusing, but it's also really interesting.
Okay. No, so don't give up. Like I said, we're gonna again break it down to the symbol level next time. Okay. But because you know every student wants to learn programming to do a hello world program, so I want to show you how assembly hello world program looks like, or even to show text what it would look like, right? But the other labs, next week lab is going to be a little easier, where you don't have to do a lot of the conversion, but we're going to do like less lines. We're going to look at like add and adding registers and things like that in our lecture and our lab. So it's going to get clearer as you go, but I wanted to give you a little harder one to start so you can see from a human side and then the computer side what it sees. Okay. All right. Yes, you can rewatch this, and if you have any questions, you can also see me or contact me, or you know, but again, I will go over in details further next time in our lecture where we start talking more about the positions of the bits and how the opcode works and all of that. Okay. Okay, so and I hope the comments kind of give you a little bit of clues on where it's at, but when you build your program and also like step through it, there are some tutorial videos online for LC3. I encourage you to kind of watch it, at least the beginning, and you know, do some tutorials so that way you can see at least the one that I attached to the lab, so you kind of see on the binary side on how that works. Okay. Okay, type your name in the chat if you finish. If you have questions, you can stick around. I'll be around until about 8-ish. And thanks for attending the lab, and we will see you next week. Have a good weekend.
See you,
I do
Dr.
have
K.
Bye. Yes.
a quick question in regards to on the lab when it tells us to add inputs. If we keep getting blanks, is that because it's in ASCII that like it doesn't register it?
What
Okay.
number are you testing?
Well, for the number 25, it said to do the symbols, and so I did the ampersand and the $sign.
Okay.
And
So,
that was just one of a couple.
Yeah, so that I'm gonna tell you why. Okay. So when you're using symbol, look at the symbol. Look at the symbol, right? Let's see. Right here. Okay. So let's say that I do a $sign. Okay. What is that in hexadecimal? 24?
Yes.
Okay. And the ampersand is 26. So when you add them together, okay, if it's above the limitation of the ASCII, it would not show you what it is.
Okay.
So
I think I
you
was looking at, oh, sorry.
can use your calculator. Okay. If I take a hex 24 and I add it with the 26, I get a 4A. Okay.
Mhm.
And
Yeah.
so if can you find a 4A on this chart for the ASCII chart?
No.
Well, so there's a 4, wait, let me see. Yeah, that if you add that 4A, it should give you a J. So if you do like symbols,
Okay.
yeah, so if I do a 24 plus a 25 in hexadecimal, I would get, so even on the decimal, that would be what, 60, 73, and 73 would be an I. Yeah, so it should give you some kind of, unless, okay, unless that it cannot store the sum value of what you add, because remember, each hex is a 4-bit.
Oh, okay. Yeah.
And then so when you have a 4A, that's an 8-bit. It exceeds the 5 bits limit in the immediate. You don't know this, but next week you will. So when you use immediate value, right? Like hexadecimal, decimal, in assembly there's only 5-bit that is used to store those values. So there's only 5-bit that we can store something that's number. So when it exceeds that, in the case where if you have 2 hex value, which is 8 bits, it overflows it, so it doesn't give you anything because it doesn't have the entire value to show you, right?
Okay.
Because 8 bits is bigger than 5-bit and it didn't have the entire value, so it doesn't give you any output. That's the limitation, is it reaches the limit of the word size.
Okay.
So to fix this program, instead of using one word, you have to maybe, when you add it, you need to make sure that the value gets stored into an array or multiple words, right? So that way it would fit larger value.
Okay. Thank you.
You're welcome. Question? Mhm.
Sorry, go ahead.
Yes.
I had a question about
Sure.
when you're trying to talk about like the subtracting 30. I still got confused even though you like repeated it again. So when you subtract 30, it's like to get the base or something like that, because you start
Yes.
at 30.
So let's look at the, wait, I should share it again. So let's look at the character on the right, which is what we see. Don't think of it a number 2 yet, right? So if you have a 2, a character 2, the hex is 32. Okay. If I have a 32 in hex, how can I show 2? By subtracting 30, right?
Wait, but wouldn't you, if you wanted to show on the screen, wouldn't you put a 32?
So yes, but for the second one, when you're subtracting it, it's because you have a 2 to start. You understand? So
Oh, so you want to get rid of it so you can be like at the clear, basically.
yes.
Okay.
Yeah. It's so basically we bring it down and we bring it back up, right? It's so when you have an input, like let's say a number 2, a 2, when the user put in a 2, right? The computer stores 32 in hex, right? So
Yeah.
if you wanted to say that is a 2, because ultimately you're going to take a 2 plus a 2, and you can still add everything and then convert it later on. That's fine. But what that program shows you is you convert it at every input
Oh,
and then move it.
so like if like you were saying that if they want to add 2 and 2, if you were to add, that means it would add 32 and 32, which would be like a completely different number, right?
Yeah, no. So it will be large, and it will not fit the size of our value that's allocated to the value in LC3. So what
Oh, okay.
happens is, because you have 5-bit, earlier you heard what I said to Alejandro, that when you use hexadecimal hex, each character is 4-bit. Okay. So when it exceeds the 5 bits to store the data, the values, the numbers, it's not going to know, it cannot convert it. So that's when you wanted to reduce it as much as you can and store it and then convert it back. So basically we're using arithmetic to make it into a 2, right? Store it and then add it back, the 30, to, and then ASCII convert it. So we can ASCII convert it. Okay. Because when we input it, the computer is going to see the hex value equivalent of it, right? And then we got to subtract it to really do the addition of it. Because if you do the addition with the hexadecimal, you're right, it's going to be a different value.
Oh, okay, I see.
Mhm.
All right, thank you. I understand now.
It's hard at first, but it's going to get easier.
Yeah, hopefully. Thank you.
Yep. Questions?
I have a question, but not regarding the lab. So I'll
Sure.
just wait until everyone finishes their lab question.
Okay, I have a question about the lab.
Sure.
For just we just upload the screenshots, and for like the document, we just should we put like what number we're answering it on?
You can paste the screenshot onto the document with the answer and just upload one document. That will be easier for you and for me. You know what I
Okay.
mean? Yeah,
Yeah.
yeah, when you do a screenshot, if I know I use Microsoft, so I just, when it's screenshot, and then I just right click on the Word document, I paste it next to the answer, and then that way at the end you just upload one document instead of uploading like a bunch of files where it takes a long time for you.
Okay, so just add those screenshots and then answer the questions.
Yeah.
Should I answer the questions underneath the screenshots, or
whatever that's suitable for you? Because I do look at it, and that's fine as long as I can find them in the assignment, in the document. That's okay.
Okay, awesome. Thank you.
You're welcome. Other questions?
Sorry, me again.
That's okay.
So with the second program that we did, where we had the two string lines, I don't know what I did with mine, but it keeps only printing out one of them.
Because you didn't do a second put?
I have two puts on here. Like I have
Show me your
LE.
screen. Can you share your screen for me?
Yeah, 1 second. Sorry, I have a couple of stuff open at the moment.
Yeah.
Is it sharing it?
Yeah.
Okay. Yeah. So I don't know. I think I must have, because I have this puts and that puts.
Oh, take out the second halt, the first halt. Remove the first halt.
Okay. That makes sense. I was like,
yeah, save and then reassemble. Anytime that you guys edit your program, you have to resave it. So file, save, and then reassemble it. And then now load it.
Okay. one of the things I'm having a hard time remembering is to continually to reinitialize. So
Well, you
this is
can still load it without and reinitialize, but sometimes you might get an error because it's still, so the simulator uses RAM and it might store something there. So you know what I mean? So
yeah. Okay, it came out this time.
yeah,
Thank
because
you.
when you halt up there, it just stops it after the first put.
Is it kind of then like with the loops if you have a break or you don't have
exactly.
properly?
If you put a break, the break actually moves, it stops it there, but halt is really just to end the program, so it just ignores the rest. It's like, forget
Okay.
it, I'm just done.
Thank you.
You're welcome. Other questions? Okay. So questions about, okay, I had a question. Yeah, that's fine. You can ask a question that's not class related. The cybersecurity healthcare certificate. Some of the courses are offered now, but it's not in the catalog. It's already approved. It just hasn't been. They are releasing the next catalog, so it should be available now. It's been approved by state, so you can I made a YouTube video and I talk about the certificates and the healthcare certificate, CIS27, CIS41A, and then some of the other classes. But I know that they're gonna publish the next catalog very soon. So as soon as I can get a hand on it, I'll let you know. Okay. Or if you want, I can give you a list of the classes. Just email me. Okay, questions? You're welcome. Okay, you guys have no more questions?
I have a question, Professor.
Sure, Zay.
Are you teaching any other classes regarding programming?
I'm working on the summer schedule. I might do like a summer Java and Python again. I don't know, because or a group of non-credit classes. And the non-credit has some programming component with Raspberry Pi and such. But for the fall, it's gonna likely be some IT classes, and then usually in the fall I teach CIS7. I haven't done 14A for a long time because, but yeah, maybe a couple programming classes. I might do a Python class, the advanced Python in the fall, and then the security for the Python and security for the fall. So those are the next two Python, and in the summer I might do an intro to Python again. We'll see. But as far as 17 series, I'm probably not going to teach that. If I teach any, it will be 17A, but there are a lot of faculty that can teach C++, but not a lot of faculty can teach like this class or discrete. So I'll take it, so I'll teach it. So are you looking to take a certain programming classes?
I was just wondering if the Python class you're teaching this semester, if it's like the entry level or.
So the one that I'm doing now has a prerequisite. It's the CIS30B has a prerequisite of A. It's like intermediate level Python. You kind of have to know like class and the basic of Python in order to get into it. And then it touches, I recommend having at least a little bit of network knowledge, but I do go over networking in that class. So we program Python to connect to using like protocols like SSH, FTP, and then automate API. Like, how you log on to an app and then you can use that app to log on to another app. Yeah, that's what we're doing right now. And then automate some networking devices, web scraping, um, you know, some fun stuff for security. And then in the security one, I teach a little bit of ethical hacking pieces with the Python. So yeah, take the 30A at least, and then that way, that one is transferable to CSU and UC now. They don't put it in assist yet. Yeah, but we articulated it. So, you know, so take the 30A first.
Do you know if you'll, when will you know your summer schedule?
By the 19th, or even right before that. I have to submit it by the 19th for everyone. So I will let you know by then that if we offer the 30A, and likely that I teach it. If I don't, it might be another faculty, but I'll let you know.
By the 19th of next month?
Of March, yes.
Okay.
Okay. Other questions?
Another question again. Sorry, but this
That's
one's not
okay.
class related.
Sure.
We wanted to know more about like how to set our schedule. I was looking at some of my classes earlier, and then like I'm taking one right now that I'm not sure if I need.
Okay. I know we're doing on the guided pathway things. They're gonna fix the website for you guys. I complain about this all the time. I'm on the guided pathway thing, so I'm gonna show you to do this the right way. And I know sometimes the counselors don't help. I went through the same thing. I took an extra class in my doctorate program. I was super upset because, it was not something I needed and I had to pay for it. And yeah, they did not like that. So they refunded me half of the class, but still it's my time. And okay, so what your major is? Are you clear on where you wanted to go and what you want to do?
Oh yeah, I'm getting doing the certification program in computer programming. I think is
Okay.
what it was.
Okay.
Yeah.
So when you look at the catalog, and they have a new catalog coming out, okay? So when you look at computer programming, let me see if I can find it. I think it's like, here it is. Okay, so you're doing an associate degree, right? With the certificate.
Yes.
Okay. So when you look at this list, if you look at the catalog, it's on page 1. The PDF is 118, but I think the actual page is 106. Okay.
Mm-hmm.
These are the required courses. Okay.
Oh wow. Mm-hmm.
And then the electives, that means that you pick 6 units out of these.
Mm-hmm.
Okay, so you can choose any of the 6. Okay.
Yeah.
So for the group 1, and then group 2, you're also gonna pick another 6. So I can do, like, for example, like I can do, let's say JavaScript and C++ 17A, or I think you took 18A. So you got this class knocked out, and then, then you have to pick one from this. I know that Castellero is teaching 12 right now. They never really offer B at Moreno Valley College since I've been there for 14B. But so you can pick any of these two of these, and then 2 of these from group 2. So you can take like 17C or B, and then you in this class, so you already fulfill one of them. And then you can take like, so pick another one from group 2, and then this one you have to pick another one.
Okay.
Because you already got A then. Yeah. And then because it's an associate degree, and I think this is an associate degree of, let me check, of science, right? You have to do all they call it the general the general education courses, that basically math, English, some physics, because it's an associate degree. And if you do the ADT to transfer to, then you have to take like certain calculus and certain physics class and certain, the whole set of English and then some arts. So as far as the CIS program classes, I can answer those for you. But for the other, the general, the general education courses requirement, talk to the counselors. They will give you the classes that you need.
I actually am all clear with those because I already got my bachelor's in English, but I came back because I really wanted to do coding, and this is the perfect opportunity. So
yeah, so all you have to do is fulfill these required. You already finished one here. Pick another one from that group. You are taking 11 already. Then you have to pick another one from the second group.
Okay.
Yeah, and then that will be the programming one. And at the end it tells you, see, 26.5 total units. So add everything up together, that should be 26.5. So anything above that is just extra.
Okay. I was really interested in doing Python, and you mentioned you were teaching one of those classes, correct?
Yeah, I did that last winter. I taught it with the Java class. I plan to teach it again. If I do it online, it might be summer.
Summer. Okay.
So that will be a CIS 30A. And I wrote the Python certificate. So it has its own certificate because we didn't want to revise. So here's the set. And it's A, B, C, D, E.
If in the situation that I wanted to get both of the certificates, like
you can.
Okay,
so
cool.
You can fulfill the one that you originally planned to do, right? You get an associate degree with the computer programming certificate, and then you can take the parallel classes, like you can take the CIS 30 classes, and we normally offer 2 at a time. So right now we're running B and D, and the next semester, in the regular semester, we're going to do C and E. So if you take 30 in the summer, you can take the security one and the advanced Python one, which has database and all of that good stuff. So together, so literally a student can knock out this certificate in like about 3 semesters. But it's designed to give you the certificate on top of your associate degree so you can get jobs, because Python is highly demanded. We have employers asking for this in apprenticeship program. I'm trying to get Jennifer to finish her apprenticeship articulation for that, so that way you can, if you have the skill, they look for that, and other languages too, but that's the certificate.
Yeah. Oh my gosh. Thank you. I'm like, as much as I love my English degree, it did not get me any jobs. And this was something that just works out perfectly because I love language, and this is pretty much a bunch of languages.
Yeah. So I'll post a flyer next week. We're gonna get it approved this week. You can certify for Python for free, or Java for free, or C++ for free right now with us if you took the class. We have for Microsoft, at least intro level anyway. So if you're ready for that, like we can set you up to take the test, and then you will get a Microsoft certification saying that you qualify for this language, and that language. And I would prepare for the test before I take it, but I will show the flyer next week. We're getting the process completed now. So okay.
Yeah, thank you so much again. Oh my gosh, I'm so excited.
You're welcome. Let me know if you have any other questions. Yeah, so I will post the flyers on the, you're welcome. I will post the flyers on the in this class, in every class, and you will see it and you can register for it. Okay. Let me stop share here and look at the chat. I don't know why, but it appears. Okay, that's fine. I figured that out actually. Oh no. Thank you for telling me that. I think I marked you absent. Let me go back and fix it. Okay, that's no problem. I think it's because you're using a device that you name it as that. It's gonna use the device name. So okay. All right. I'm gonna sign okay. Okay, yeah, I'll fix that. I'll fix your attendance for you. Thanks for letting me know. I thought it was another student because there's another person that has that initial. So I thought it was that student. Okay, I'll fix your attendance. Okay, well, I'm going to sign off if you don't have any questions for me. And then I'll see you next week if you have questions. Okay, that's fine. Just try to catch up if you miss anything. So we did the work, just try to catch up and complete it, okay? You're welcome. Good night. Bye. Take care.